On this question again. So this was the grocery store in 2017 AP question. So we had initially 50 pounds of bananas on a display table. Customers came into the store and were removing them at this rate, and then the employees were adding them at this rate. So our goal was to talk about what came in, what came out, and then how much we initially started with, and we wrote an equation based off that. We said we had an initial amount, the amount that came in we integrated because it was pounds per hour, and then we subtracted the rate that they came out, again in pounds per hour. I don't know if it was the bottom, did we do that part A? Looks like I did on this. How many pounds of bananas are removed? So we said we're only going to look at the removing function from 0 to 2, and we've got this many bananas. My papers are all kind of coming apart here. Part B, looks like, do I have the right book? Is this your class? Okay. So we found F prime, we talked about the rate, the units for F, and then the units for F prime. And then we wrote this derivative in context question. All right, so on to part C. It says, is the number of pounds of bananas on the display table increasing or decreasing at t equals 5? Give a reason for your answer. Okay, so let's think about this. So I'm looking, I want to know if the number of bananas is increasing or decreasing. So what I would want to compare is the rate that they are being put on and the rate that they are being taken off. I want to compare the rates, basically. So I want to find f of 5 and g of 5. And I'm just going to make a note. My f was in y1 and my g is in y2. So I just want to, on my home screen, I just want to find y1 of 5. And again, it's going to get me 13.796, and F is measured in pounds per hour. And then find G of 5, find your Y2 of 5. Does 11.533 sound right? And again, that's measured in pounds per hour. All right, so I can hopefully convincingly say that this number is greater than this number, and f of t again represents the rate that they are being removed. So I can say the number of pounds of bananas, and again, I'm just using the context of the question, what I underline, the number of pounds of bananas. Would I say increasing or decreasing? Which one's greater? F or G? F, and F is the question or the discussion that's being removed. The number of pounds of bananas is decreasing at t equal 5. Since f of 5 is greater than g of 5. Okay. So I'm losing more bananas per hour than gaining bananas per hour. Make sense? So they would be decreasing if it's going faster. Part D, how many total pounds of bananas, so I want the total pounds of bananas, are on the display table at t equals 8. Okay, so I have to write an equation for the amount of total pounds of bananas. Okay, so again, I want my units, I want everything to be about bananas. So again, I want to make sure I start with my initial amount of bananas. How many bananas did we say we started with? 50. And then I have some coming in, which would be a positive amount. Now, those units on the ones that are coming in are bananas per hour, and I'm writing an equation about bananas. So I have to integrate from 0 to t. And again, we just have to call this something else. I'm going to call it g of x instead of g of t. And then I want to take out the ones that are being removed from 0 to t of f of x dx. Are we clear why we're integrating? This is pounds per hour. I want pounds of bananas. Pounds per hour. I want pounds of bananas. All right, and now I just need to find a of 8. And again, I'm just going to substitute. This is why I need those different variables. I just want 8 in the integral, not in the actual function. And you can type all of that in your calculator. Again, I made a note to myself that my F is in Y1 and my G is in Y2. I might just put a little note under there for myself so I remember. And we'll round to 3 decimal places there. Type it in all on one line, just the way you see it on your paper. Is it like a 41 number? Yeah, we need a 41 number. And again, 3 decimal places. And then our units, of course, are bananas. Did you not put that in? It's you now.
Because I put this in Y1.
In Y1. I think you did it right.
Oh my gosh.
Yeah, I think it's 0. Yeah. Anybody else not getting that number?
What was supposed to get?
A 41 something. Did you type it in today? Oh, this is your removed, right?
Yeah.
So you want to remove the, right.
Okay.
Yeah. Fran, did that come out any better? Yeah. Okay. All right, now the bottom of my book fell apart. Did that cover the whole question? Is that all the parts of that question? Yeah, okay. So again, this is a typical in-out question. We're going to play with a couple more of these. Like I said, this is a pretty big concept when it comes to the AP. You're definitely going to see one of these. And we want to do our best job at getting as close to a 9 that we can here. So we're going to flip back to, let's see, who's got a good one? Let's try page 363. Page 363. It's this nice little elephant at the top. Again, you can see that's an AB question. So sometimes you'll see AB/BC. 50% of the BC exam is the AB exam. So they'll have 50% AB questions, 50% BC. So we'll have a couple questions that are the same. That's all that means. So again, this was a 2010 question. It was on both exams, and a calculator is allowed. Okay, so we have a zoo sponsored a one-day contest to name a new baby elephant. Zoo visitors deposited entries in a special box between t = 0, noon, and 8 p.m. t = 8. The number of entries in the box after noon is modeled by a differential function E of t. All right, so we're going to have to talk about the context of the problem, so I just kind of start underlining. E of t is the number of entries in the box. Okay, so that's what this question is about, the number of entries in the box. Values of E of t in hundreds of entries at various times are shown above. So again, E of t is in hundreds of entries, t is in hours. Let's see, I'll give you let's go ahead, get A and B. Let's pause it for 2 or 3 minutes and tackle A and B. And it is calculator active. to explain that value. And think about your value. Does it make sense based off the table? Nothing to do with this problem. All right, so typically in these in-out questions, A and B are super nice, B and C, or C and D are gonna make you work a bit. So hoping, again, walking around, almost everyone, I think everyone nailed A, B we're almost all close on, and then we're gonna work at C and D here. So I'll go over A, but I think everyone had it. We wanted to approximate the rate at 6, so we are simply looking for the slope at 6. So we would want E of 7 minus E of 5 all over 7 minus 5. So that was 21 minus 13 over 2, and that got us 8 over 2 or 4. And then again, we're just going to talk about the units. I had hundreds of entries on top divided by hours. So I should get hundreds of entries per hour. Okay. And again, I think, and I don't mean to say dummy proof to insult anyone, but like you're literally just going to copy the units here and copy the units here. We shouldn't be able to screw that up. All right, part B, and it didn't ask you to explain that, right? Just show computations. Done. Part B, we wanted a trapezoid. Okay, so obviously we have to know that formula. 1/2 base, height 1 plus height 2. 4 subintervals, which broke up real nice between 0 and 8. But here's the thing a couple of you missed. Some of you got it, but a couple of you missed. You're finding this. Not only are you integrating, but you have to multiply by 1/8. So I want to say 1/8 the integral 0 to 8 of E of t dt is equal to 1/8 my trapezoidal Riemann sum. I have to take 1/8 of my approximation. Now, would you agree everybody in here is going to have a base of 1/2 or 1/2 in front of it? I'm just going to pull the 1/2 out also. You don't have to, but I'm just going to do it to make my life a little easier. So if I look at the first base, the base should be 2, and the height should be 0 plus 4. Looks like the next base is 3, 4 plus 13. Next base is 2, 13 plus 21. The next base is 1, 21 plus 23. Okay, again, I could put a half on each of them, or I could just pull it out front since they all have it. But don't forget to multiply by this 1/8. Okay? I think I got, does a 10.688 sound right? And then Christian, was yours just, if you divided by 8, did it work out? Beautiful. Okay, so I think the math part fairly straightforward there. Using the trapezoidal sum with 4 subintervals, approximate this. Now, using correct units, explain the meaning in the terms of the number of entries. So again, you have to talk about the problem. That's why we underlined it here. We integrated E of t, which is called the number of entries in the box. And by putting this 1/8 out front, what did we find? The average number of entries in the box. Okay, the average number of entries in the box is 10.688. What are my units on that? Yeah, I'm gonna add one bit to that, hundreds of entries. Hundreds of entries. From t equals 0 to t equals 1 hour. Or t equals 8 hours, sorry. T equals 8 hours. Okay. So again, we're just using the same lingo that the question's using. Underline it and just keep referring back to that. That's what we're talking about. All right. Like I said, A and B, usually the entire country gets. C and D is what separates you from everybody else, okay? So part C. At 8 p.m., the volunteers begin to process the entries. All right, so they collected entries from time equals 0 to 8, right? So you're allowed to put your entries in, that they closed it, and now they're going to start processing it. So they're looking at the entries, right? They're going to figure out we're going to name this baby elephant. They process the entries at a rate, so this is a rate of P of t, which is in hundreds of entries per hour. Okay, so again, pay attention to the units. They're giving you hundreds of entries per hour. Here's the question. According to the model, how many entries have not been processed? How many entries have not been processed? So let's just use some common sense. Like, I think this is kind of like an elementary idea. You would have to know how many you had, and then how many you are processing, and what's left over is how many you have not processed, right? This is what I have, this is what I processed, what I have left over is what I have not processed. So, how many, let's write an amount, the amount that we haven't processed. How many entries are we starting with when we begin this? And we're starting at 8 p.m. So how many entries do we have in the box? 23. Okay, now we're going to process them, so we're looking at them, right? We're going to take them out. Now I'm given P of t, which is hundreds of entries per hour. So do I want P of t or the integral of P of t? Integral, because I'm trying to find entries. So I'm going to integrate from 0 to t of P of x dx. So I have 2,300 entries in the box. When I integrate this, this is how many entries I have processed. So what I have left over is how many I have unprocessed. So all I have to find is A of, at what time are we doing this? Hundreds unprocessed, according to how many ended up by midnight? A of 12. So I have 23 minus the integral from 0 to 12 of P of x dx. And again, just throw that in your calculator. Now, just, here's what I would do real quick, just because I know what the next question's leading into, we might as well just throw this in y1. We're going to need this eventually. X cubed minus 30x squared is 298x minus 976. So I have 23 minus integral from, oh, it's not from 0 to 12, I just caught myself, sorry. What time did we start processing these? 8 to 12. Just caught myself there. From 8 to 12. And remember, it's not 7 entries, it's actually 700 entries. Okay, because that was measured in hundreds of entries. All right, part D, this is the big one. According to the model from C, at what time were the entries being processed most quickly? Okay, so I want you to highlight that word most quickly. This is, again, another way to say if you're the most, the highest, the fastest, the quickest, it's another way to say it wants an absolute max, which means it goes back to that T-table. If you didn't draw a T-table in this exam, we know we did something wrong. There's going to be one on every single one. Okay, we want to find the way we process them most quickly. So I know I need my T-chart. My times, again, are endpoints and critical points. Okay, my endpoints are clearly 0 to 8. That's what this table went from. And I have to get my critical points. Okay, so again, my critical points, and we're talking about the entries being processed. What function represents the entries being processed? P of t. Okay, so we're talking about function P of t. That's what's going to go here. I want to know when they were processed most quickly. Now I have to get my critical points. So again, a critical point is when the derivative equals 0. So I'm going to set that derivative equal to 0. Now again, I'm going to solve this graphically. It's a graphing calculator question. So let's set our window from 0 to 8 and graph that function. Oh, sorry, we got to graph the derivative of the function. Oh, Jiminy Crickets, am I losing my mind? They're not even being processed. Hold on. See, this is why this makes you stand out. I'm not even reading the question. They didn't start processing from 8 to 12. Sorry, I got to use P of t. 8 to 12. Sorry about that, reading the wrong values. P of t is only turned on from 8 to 12. Okay. Now, I want to set P prime equal to 0. Who do we have in Y1? P of t. We have to take its derivative and set it equal to 0. So we're going to turn off Y1. And in Y2, we have to derive that function. So again, you don't need to do it by hand. Just hit Math 8, derive the function in Y1. Now, when you're on a graph, you don't want to do a moment in time. You want to do it everywhere. So we always put an X in when we look at a graph. We want to derive it at every X value. Okay, so I have my function in. I need its critical points. I'm taking its derivative at Y1, and I'm taking the derivative everywhere, so at every X value. So the derivative of Y1 at X. So again, the critical points are when this derivative equals 0. Happens here and here. We need to go get those values. So use your second trace 0 to go get those values. And again, 3 decimal places. I'm getting a 9.184 for one of them. Grab your other one. Does 10.817 sound right? James, did you get that? Good. Okay, so once I have my critical points, and again, I needed critical points and endpoints. I had to use 8 to 12 because we're talking about this function. We just want to know when they're being processed, so they're just going back into P of t. So in this case, my P of t is here. I'm just finding P of 8, P of 9.184, P of 10.817, and P of 12. Okay, so I'm just putting them back into P. Now again, where is P sitting? It's in Y1, so I'm just going to pull up Y1 of 8. I've got a 0 on that one. And then just get them all in there. Y1 of 9.184. And then I got to just make sure I answer the question. According to the model, at what time were the entries being processed most quickly? So most quickly looks like at this value, so I would say at t equals 12. The entries were being processed most quickly. All right. Hopefully I dusted off the cobwebs here. Sorry about that. All right, let's try another one. Turn to page, let's try this one. Page 365, number 4. The memes question. Posting memes. After the AP Calculus exam, students post memes at a rate of M of T, where M is measured in students per hour, and T in hours after the AP exam ends. After 12 hours, ETS and the College Board begin canceling scores of students that posted memes at this rate for 12 to 24. This is actually a true fact, so don't post anything after your AP exam until they say that time is up. Where C is measured in students per hour and T is in hours. All right, so there's a lot of information here. So M of T represents students posting memes, and that's in students per hour. Gotta highlight all this for myself. C of T represents the College Board canceling your scores, and that is also in students per hour. And S of T is the number of students, so S of T is students, who have posted memes but have not yet had their scores canceled. Okay, so again, this is a true idea from the College Board. Be careful not to post anything after, and we'll talk about that again. You do sign a legal document saying that you won't do that. Part A, after 24 hours, how many students have posted memes? Round your answer to the nearest whole number. So take a moment. Hopefully that takes 60 seconds. How many students have posted memes? I'm going to go get these functions in here because I know we're going to need them. 231 sine pi x over 24. Two, 6, 4, 3, 9 x squared over 24. All right, so like when I say 60 seconds, it probably shouldn't take us that long. Posted memes, which function are they referring to? M of T? So I'm literally, and M of T was measured in students per hour, and I want students. So to go from students per hour to students, I simply just integrate, and it says the first 24 hours, so from 0 to 24 of M of T dt. Simple enough? Okay. Highlight, think units. It's all about units. And I put that in my Y1, so I'm going to go math 9, 0 to 24, Y1. Round to the nearest whole number. So I am getting 3,529 students. Okay, part B. At t equals 19, is s of t getting larger or smaller? Okay, so now we got to figure out what s of t is. So let's make a note here. S of t is, what are the units of s of t? Students, right? So I need a whole equation about students. Students who have not posted memes. So I know students that have posted memes, students whose scores were canceled. So how would I get the students whose scores weren't canceled? I would just do what with those two? Subtract. Okay, so now let's talk. Do we want those functions or do we want their integrals? If this is students per hour, and I'm writing about students, I definitely need to integrate from 0 to t of m of x dx. And now we're going to take out the ones we're canceling, and those were students per hour. So I'm going to subtract the integral from 0 to t of c of x dx. All right, now let's think about this. If I just plug this in, I don't actually know if they're getting larger or smaller. I want to know basically if something's increasing or decreasing. So to think, again, just think basic. If I want to know if something's increasing, I have to look at its what? Slope. So I have to take this guy's derivative. Okay, so now we need to go to the idea of that second fundamental where we take the derivative of an integral. The derivative of the integral rule just takes the upper bound and plugs it in. So I'm going to get m of t, and then times the derivative of the upper bound, which just happens to be 1 in this case. Then I have minus derivative of an integral. We're taking that upper bound and substituting it in. So that's c of t times 1. Again, that's the second fundamental. So now all I really need to find is s prime of 19. So that's just going to be m of 19 minus c of 19. And again, that should be in your y1, y2. So carefully evaluate that. Oh, I need s prime. So I have to take its, nope, I just need m of 19. Man, I'm out of it today. M of 19 minus c of 19. How does negative 19 point something sound? 425. Oops, 425. So again, this was in y1, y2. So now it says make sure you explain your answer. So again, I haven't actually said if it's getting larger or smaller. In this case, I would say s of t is getting smaller since s prime of 19 is less than 0. All right, part C. At what time is the number of students that have posted means and not yet have their score canceled a max? So what equation represented the students that posted memes and not had their scores canceled? S of t, right? They're just asking about S of t, and they want to know when S of t is a max. That is really the question. When is S of t a max? So again, to find a max or a min, let me just, again, think calculus. If I have a max or a min, talk calculus, what do you know about it? It's what is what? Its slope is 0. So my game plan here is I have to set the derivative equal to 0. Every time I see max or min, I'm going to set the derivative equal to 0. Okay. Now you don't have to guess whose derivative because they described S of t. So our goal is to find S prime of t and set it equal to 0. Okay, now we actually already know S prime from up here, right? So S prime of t is equal to m of t minus c of t. And I just want to set that equal to 0. And we're going to pick up on this tomorrow. And I still don't think we got as far enough to give any homework tonight. So don't get too used to this, friends. We're going to go one more day with our, whatever we're doing here, in and out questions. And then we'll start our new topic next week. Since you have no homework, if you're desperately bored, I do have the spiral for next week if you want that. You want that? All right, I can give you that.